and we can pass to the second project that we have on agenda. I will give the floor to Beatriz.
Hi, everyone. So give me 1 second. I'm going to share my screen. So I think that now you can all see my screen in full mode, isn't it?
Yes.
Okay. Okay, so well, hi everyone. So as I said, my name is Beatriz Martínez Pastor. I'm the project coordinator of the SETO project, that is a smart enforcement of transport operations. So what I will do in this presentation, I will present an overview of the project, what are the main objectives, the case studies that we have, and then on the second part that is assigned to this project that will be presented by Saša, he will focus more on some of the technical aspects of the platform that we are developing. So just to give you a quick overview of the project, so the SETO project is a sister project of KEYSTONE. So both projects, they were funded under the same European call. So they are both research and innovation actions from Cluster 5, that is a cluster for climate, energy, and mobility. And the SETO project, I think that is similar to KEYSTONE, is a 3-year project, and we started in 2023, in June 2023. So we have been working now on this project for more than 2 years, and we have less than 1 year to go until the end of the project. The overall budget of this project was a bit more than 4 million euros, and we managed to put a very strong consortium together to try to achieve the main objective of SETO. So as you can see here, we have 14 partners from 7 different countries across Europe, and we have representations from all the main actors. So we have universities, research institutes, small companies, large companies, governmental agencies, owners or stakeholders of the infrastructure. And all of this was done in purpose to try to achieve these next steps on the enforcement of transport operations. So as you know, and as you have heard from the previous presentations, you know that the data ecosystem that right now we have on the European Union is still quite fragmented. So it's not easy for European authorities to collect all this data, all of the data that they need in order to do the enforcement of any type of regulations that they want to apply. So the main objective of SETO is to try to create a tamper-proof open source digital platform that is able to gather all this necessary data, whether they are coming from digital or from physical sources, in order to achieve and to make it easy this smart enforcement in a secure online database. So in this way, by putting together all this data, the platform will enable enforcement authorities to reach the applicable regulations simultaneously with the relevant data collected from all the resources in a unified, understandable report that will help the officer to make a justified enforcement decision quickly and also efficient. So this is the main goal that we have within the SETO project. But of course, this is not the only one. So we have identified like 6 key objectives, and the number one that you can see here is the one that I mentioned, that is the development of the digital solution for the SETO's smart enforcement system. But also we will focus on other aspects that still need to improve on the technicalities to achieve this enforcement. So the second one that you can see there is the directly enforced vehicle load regulations to ensure safety and reduce the impact on the environment and infrastructure. So we are trying to improve how we can estimate the load on the vehicles. So I will explain a bit more about this later, but the algorithms that we have right now, they don't have the accuracy to be able to do it to control all the trucks with technologies like the weight in motion. So we are trying to improve the algorithms and the models that are available nowadays. And the third one will be on the enforcement of positioning regulations, so based on reliable GNSS data. So again, here is another very technical aspect of the project, because we know that when we want to do enforcement of the position regulations, when we are working in urban environments, sometimes the GNSS data, they don't have enough accuracy to do the enforcement. So again, we are working on the algorithms and the technical part to try to improve the accuracy of this data so the enforcement is possible in this area. Then the fourth objective that we have for SETO is, of course, to validate and to roll out the living labs. So we have 2 living labs, one in France and one in Belgium, and I will do like a quick introduction to these 2 in the next slides. And the fifth objective is on the area of creating an ecosystem of stakeholders with realistic pathways for SETO's impact. So we know that without the stakeholders and without bringing them on board from the beginning, it will be difficult that the outcomes of the SETO project will become a real thing. So we have been making sure that we bring stakeholders from the beginning during the creation of the platform. So if it is something, so what we are developing within SETO is something that is useful for them and that they will put into use in the next few years. And finally, there is another objective, that is the last objective, that is to maximize the SETO's outcome and analyze the technological, economical, social, and environmental impacts of the type of solution that we are presenting. So again, we are trying to cover all the key aspects of the development of these type of solutions. So we try to maximize the impact that we will have with our outcomes within SETO. So moving on, since you have been hearing a lot about Keystone, I have put this slide here together so you can have an idea of what are the challenges, the opportunities, the synergies, because as I said, these are two sister projects that were funded under the same call. So here you can see across the challenges, there are many challenges that are shared for both projects. So we have multiple non-standardized data sources that we are trying both projects to integrate. So SETO is doing this through a data integration platform, and Keystone is working on this more on the app solution and standardized APIs. Another two important areas will be the data document manipulation that SETO is trying to improve with tamper-proof technologies, and a paper-based control processes. So SETO is presenting a digital solution to try to reduce as much as possible the paper-based approach that it still exists in many areas and in many modes when we are doing freight transport. Then also another challenge that we have seen is the access to European platforms such as Resper and Taconet. So these two platforms are still very difficult to access and to connect. So we are doing a proof of contact with other open platforms, and we will prepare as much as we can the connections with these European platforms. So in the future, the connection is easy. Then another challenge is the transport workers' social conditions. So we are doing, as we have seen, we not only need to bring the stakeholders on board, also we need to make sure that the solutions that we are proposing, they are easily accessible and transport workers can upload the data. So we are doing research within the project on uptake of soft enforcement approaches and how this will connect with the day-to-day work of the transport workers. And another challenge will be bringing enforcement authorities on board. As mentioned, stakeholders are key on the engagement of this type of platform. So we have been developing multiple workshops, mainly in Belgium, in Italy, but now in the past few months also we have introduced some workshops in France to try to work with the enforcement authorities. So the uptake of this type of solutions is easier. And another two challenges, of course, it will be the creation of a business model that SETO and Keystone, both of them are working on this. So once the platform or the outcomes of these projects are presented, they are easy to take with this business model. And then delivering high impact pilots that I will present now about the pilots that we have presented within SETO. So we have been trying to work, as one of the examples is this webinar, we have been trying to work a lot together with the Keystone project to try to see, even though we are funded under the same call with the same objectives, I think that we are trying to propose slightly different solutions, but both of them can work very well together and to achieve a better solution for the smart enforcement of transport operations. So together, as I mentioned, there are other challenges that are more SETO specific that will be ensuring the reliability of enforcement by WIM systems, which will be addressed by the developing of a Blue Guide and metrological recommendations. So this is something more technical and specific to SETO to try to increase this weight in motion system so the accuracy is better. Also, the transferring of technologies from road transport to inland vessels, which will be addressed by attempting to develop a taco-like device for vessels. So we are not only working with trucks, we are also doing some multimodal transport operations, including vessels. And also we have another challenge that is on the environmental impact of transport, which will be investigated in the context of SICAM and the impact of overloading in the road infrastructure. So trying to understand how the change to these new SICAM technologies will have an impact on the environmental aspect and also on the safety aspect. So, as I said, one of the key solutions from SETO will be these digital platforms. So I won't go into details now in this slide. So there has been a lot of work on this platform that will be presented later on by Saša. And also we have done the connections by different ways. So we have done direct connections and also direct connections through some of the softwares that the companies like ZF that are part of our projects will have. But again, all of the details about this will come in the next presentation. So I will focus now and do an overview on the living labs. So of course, another essential part of the SETO project will be to test the technologies that we are developing in the living labs. So for that reason, we have two important living labs. So the first one is in the A63 motorway that is going from Bordeaux to the border with Spain. So this motorway is being run by Atlantis, that they are part of our consortium, and is a strategic link for Europe with an annual average daily traffic of 90,000 trucks, predominantly Class C trucks, and they usually are international trips. So in this motorway, we have two WIM systems, one in each direction of the traffic, covering two lanes, the right and the medium lanes. And we have WIM systems near the south toll gates and to the north to south flow. And also we have a WIM system near the north toll gate direction to the south to north flow. In these WIM systems, we are collecting, of course, like a huge amount of data. So the data provided that we have from this site are the axle weights, the cross vehicle weight, the axle spacings, the length, and also the wheelbase. And this is being complemented with a series of cameras that will allow the identification of the trucks by the license plate. In these living labs, also the axle weights and the GVW measure by the WIM system will be validated using a static scale at the toll gates for random trucks. So we have the possibility of making sure with these static scales that the data and the accuracy of the WIM system is as we need it. So as you have seen, this living lab is more focused on the trucks, but then we have another lab that will focus on a multimodal pilot. So this one is taking place in Belgium. In this one, we are monitoring at least 18 trucks that are installed with ZF Transix hardware from different companies. So we will have trucks from Tienpont and also from the Grot. We will also have vessels and ships that will be monitored. And the plan is also to include within this last month some last mile delivery bikes or vessel ships to try to also focus on the monitoring of this last mile part of the logistic process. And some of the trucks will be equipped with accelerometers that will be able to test the onboard tamper-proof weight in motion algorithm. So as I mentioned, we will use the weight in motion approach with accelerometers that are located in the truck, and we are trying to improve the accuracy of the algorithms to be able to reach more than a 95% accuracy on this area. So together with the living labs, we have been also working a lot on the identification of key stakeholders. We have identified more than 62 so far. So we have been in touch with transportation and logistic operators, with economic operators, with civil society organizations, with infrastructure managers, and with public authorities. So we are trying to reach as many stakeholders as we can. So if anyone that is part of this webinar is interested and want to be part of this stakeholder ecosystem, please just let me know, and we'll be happy to organize an interview with you so we can collect all your inputs that can be brought into this SETO project. And as part of this stakeholder ecosystem, we have been developing a stakeholder engagement with interviews and workshops. You can see here some examples of the ones that took place in Belgium. So we included the label, the Flemish Tax Authority, CIOT, the Belgian Federal Social Inspection, Belgian Customs, Belgian Federal Road Police, and then another one that we had last year in Italy, in Modena, with the municipality of Modena, Comune di Modena, and also ITL, that is the Institute for Transport and Logistic Foundations. These are just two examples, since we have also produced other workshops and interviews in other countries for the stakeholder engagement. And finally, as I said, just to let you know, so if you go to the website of SETO, now you will be able to access a lot of information and deliverables that are already published. So now we have less than 1 year to go. So there has been a lot of work that is already published. So please make sure that you go to the SETO website and all the information you can download there. Everything that has been presented and is open source right now is on the website. So I'll finish here for this overview of the project, and now you will hear more about this platform of SETO from Saša.
Thank you so much, Beatriz, for this. Saša?
Thank you, Beatriz. Yes, I will try to be fast. Once again, I'm Saša Klopanović from Mainflex Labs, one of the partners of the SETO project, which is providing the SETO digital solution. Beatriz already mentioned that the SETO is actually was conceived to provide all relevant information that are necessary for the smart enforcement of transport and safety legislation in real time. What this diagram shows is actually that it's conceived as a modular tamper-proof middleware created as a set of microservices, which is now standard for this kind of let's say industry platforms, which gather data from all relevant sources deployed in vehicles, like from tachographs, electronic control units, onboard technologies, but also web stations. And as Beatriz said, we will try to gather data from EU platforms. So one of the basic features of the SETO is a multi-tenancy, also industry standard, but in this context is very important, which enables to securely operate with the shared digital ecosystems, but also keeping the data, devices, and operations completely isolated. In that way, it's cover the data sovereignty, protect the GDPR compliance, and cross-border collaboration. As you can see from this simple diagram, it is a three-tier hierarchy with organization, groups, and users, where users also have actually individual members roles which with different privileges as owner, administrative, editor, and viewer. In that sense, with this access control and then data governance mechanisms, all data, dashboards, and device records are only visible with an assigned group. Each organization administrator can configure its own internal hierarchy and selectively share data sets with other trusted tenants. And finally, we also implemented the blockchain, actually the decentralized identities derived from the actually blockchain, which have integration for secure, verifiable digital identities for all devices, users, and vehicles. One of these, actually, I would like to say the particularity of the SETO is that we provide two dual interfaces, one for administrative user interface and one for the end users. So the administrative part is for more technical people to manage users, especially what is most challenging devices and permissions. And another one on the top layer is for end users, for all the stakeholders that are relevant for us. Just a quick overview here. Administrative technical person can, as you can see, manage groups, devices, and memberships. And one of the crucial features is this rule engine, which automatically analyzes all incoming data for weight, position, or cabotage against all the predefined enforcement conditions. And when some threshold is exceeded, like, for example, a vehicle overweight, it triggers alerts, actions for inspections in authorities in real time. On another hand, this is the end users user interface. This is example for position enforcement, in which list of vehicles and all relevant data for vehicles, including the indicator of evaluation, are presented. And similarly, for the weight enforcement, end user can check on particular rim station, measure tracks with all the relevant data for overload monitoring. The core aspect of the SETO platform is device and connectivity management. As I said, the platform support integration with various range of devices. Here is one simple example for data scenario relevant for logistic operators, which already are using kind of logistic management systems like our partner of the project, ZF Transit, is providing. As you can see, we are collecting data from their devices and their platform and feeding it in the SETO platform and finally in the blockchain. But also for the authorities who doesn't have, of course, this kind of management platform for the industry, we can also, and this is what we showcase in our demos, can retrieve the relevant data directly from the vehicle, like it is shown here. Finally, this is the more a little bit complex setup for onboard measurement, which was explained. So this real board measurement goes from the trucks and proceeds in the SETO platform, where is compared with the data from the either static or V measurement stations. And finally, as you can see in all three use cases, all data is pushed to the blockchain model, which I will explain a bit later. Finally, this is one of these most important things that are mostly challenging as well, but not from technical, but more from the administrative perspective. As Beatriz explained, it's an integration with all these relevant new platforms. Finally, I will not go too much in detail. This is the blockchain part of the SETO platform that is also crucial for security, but also for the consistency of the data. I will only say that all stakeholders can validate data source consistency by comparing the hash, it's a technical term for blockchain, stored on the blockchain with their locally maintained record. Beatriz went in the details about backside of the pilots. Here you can see it from the perspective of the SETO platform. This is an example of the particular truck, actually driver, and this screen showing is all relevant data regarding the driving and resting times with the violation indicator. And also on the right side, you can see enforce button, which enables reporting the violation. And additionally, notes concerning this particular driver can be submitted both by operator, logistic operator, or authority personnel. On this screen, on the other side, we are showing the weight measurement station with their basic info, like type of the measurement station, static or film, or location, and type of technology which is used. And when you click on the particular station, you can see the trucks and their relevant info for the weight measurement by the station or board technology. And finally, the screen presents all relevant weight measurement data. In this case, for the purpose of comparison between bin station, we can compare measurements with the onboard measurement, which is, I said, one of the very important aspects of the SETO. And finally, thank you for this. I would just emphasize that SETO brings technology, policy, and I would say the trust, which is always important in the enforcement. And it's operational open source middleware integrating, I hope, in the future also the EU databases, not all of these devices. We showed with these demonstrators that are, transparency and compliance by design. My also goal personal was that it should be as much as user friendly for all people, especially the authorities who are mostly not technical people.